In this video, let us see how to draw the schematic of CMOS OR gate. In order to draw the schematic of CMOS OR, first you draw the schematic of CMOS NOR and place NOT gate at the output. We know that the Boolean expression for NOR gate is y equal to a plus b whole bar. Here plus means parallel. So place NMOS in parallel and place PMOS in series. So let me place the components. Click on F2, search for PMOS. They should be connected in series and NMOS should be connected in parallel. Arrange them properly. So in order to move a component, click on F7, select the component and move it. So for NOR gate, it is y equal to a plus b whole bar. So plus is nothing but parallel. So NMOS is connected in parallel, whereas PMOS is connected in series. Now try to make the wiring part. So at this point, I'll take the output. So this is a schematic for CMOS NOR gate. Now, in order to get the OR gate, place the NOT gate at the output. Means for this wire, you need to connect the NOT gate. So place the component PMOS. Now place the NMOS. Click on F2. Search for NMOS 4-terminal device and place it here. Make the necessary connections. So at this point, I'll take the output Y. I'll extend the terminals for inputs. Okay, so if you observe here, this first part is CMOS NOR gate and this one is CMOS NOT gate. So OR gate contains 2 inputs and 1 output. So 2 inputs are A and B and output is Y. So let me give inputs for which I'll place the voltage source separately. So this V1 is for input A, V2 is for input B and V3 for supply voltage VDD. Place the ground terminal and make the necessary connections. So label them. So right click on this V1 and rename it to input A. This one is B. This is supply voltage VDD. Place the labels. A, which is of type input. This is B. So right click on it and try to rename it. Next one is supply voltage VDD, which is bidirectional. Now try to apply the voltage. So I want VDD as 5 volt. And for B, I will apply pulse. So initial value is 0. On time is 5. This on is nothing but when it is on, it will be logic 1. So it is 5 volt. Delay time is 1 nanosecond. Rise time is 1 nano. Fall is 1 nano. And I want on time period as 5 nanoseconds and the time period is 10 nanoseconds. Similarly, apply for A, which is of type pulse. This will be 0, 5, 1 nanosecond. Now I want on time period as 10 nano and time period is 20 nanosecond. Okay. Now here you have to label them according to the inputs. So this is A and this one is also A. Next input is B. This point is for VDD. Place the ground. And this output is Y. So output is Y. Place it here. So this is a schematic of CMOS OR gate. Now if you observe here, this body terminal is in floating state. For PMOS, this body should be connected to supply and NMOS should be connected to ground. So I'm done with the connections. Now I have to simulate it. Click on simulate, run. I'm going for transient analysis. I want stop time as 100 nanosecond. So let me close the previously opened schematics and waveforms. So these are something which are generated previously. Now I want to delete them. So click on delete in your keyboard and choose it as V of A and V of Y so that this part get deleted. Now I want 3 plots total. One is for A, another one is for B and output is Y. So I'll add one more plot. So click here and choose the input. Input is A. This one is for B. This is output Y. So for this particular CMOS OR schematic, I got some waveform. Now let us try to analyze this waveform. So let me zoom it. So if you observe here, this green color is for input A, blue is for input B, and red is for output Y. So if you observe 1 plus 1, so 1 plus 1 is nothing but 1. Next 1 plus 0 is again 1. 0 plus 1 is 1. 0 plus 0 is 0. 1 plus 1 is 1. So it is satisfying the truth table of OR gate. So this is how we need to draw the schematic of CMOS OR gate and generate the waveform for it.